Question is, a group of 7-week-old chickens reared on high protein diet weight. Weight of first group with high protein diet is given. Second group of 5 chickens treated with the low protein diet. Weight of low protein diet chickens are given. Test whether there is a significant evidence that additional protein has increased the weight of chickens. We will test this by add 5%. Now first by SPSS. Variable view is there. First protein, then decimal changes to 0. Label it as protein. Now in protein category 2 values are given. First high protein, label it as high protein, number 1. Number 2 value is low protein, label it as low protein. Then align to centered. Nominal scales just for the sake of numbers, number 1 for high protein and number 2 for low protein. Then second variable is weight, label it as weight, no missing value, aligned it as centered. Measurement scale is, so 2 variables are there, protein and weight. Now data view. We have first 7 observations with high protein. Put it as 1, 1, 1, 12, 15, 11, 16, 14, again 14 and 16. And next 5 observations with low protein diet, means second group. Name it as 2. First one is 8, 10, 14, 14, 10, and last one is 13. We have total 7 plus 5, 12 observations. See here, first 7 for high protein and next 5 for low protein. First group high protein diet and group number 2 low protein diet. 2 independent groups are there with 7 and 5 observations. Now to analyze. Compared mean, independent samples t-test. Click over here. Test variable is weight, shift it to right side, and grouping variable is protein, as 2 groups are there, high protein and low protein. 1 is our high protein and 2 is our low protein. Continue. 2 groups are there, so this is our grouping variable protein. 95% confidence interval or 5% significant level. For testing the hypothesis, we will test at 5% significance level. Press OK. This is our 2 tables SPSS output window. Group statistics and independent sample test. First we will explain group statistics. Weight is given, proteins, 2 categories, high protein and low protein. 2 independent groups with high protein and low protein, where number of observation in first group is 7 and in second group is 5. Total number of observations are 12. Mean of first group is 14 and mean of second group is 11. Then standard deviation is given. Lower the value of standard deviation indicates that the value tends to be close to the mean of the group. Here value is 1.9 and 2.4, which is quite lower than standard error mean. Standard error mean. Formula for standard error is standard deviation divided by square root of number of observations. It measures the accuracy with which a sample distribution represents population. Mainly it measures standard error tells how well the sample mean estimates the true population mean. How well the sample mean estimates the true population mean. Means how well the sample is representing the population. Population mean. And number 2, smaller the value of standard error would mean that population is in uniform shape. Smaller the standard error implies population is in uniform shape. Write one more point over here. Point number 3, larger the standard error indicates lot of variability in the population. Means larger value of standard error implies variability in the population, fluctuation in the population, perturbation in the population, dispersion in the population, variability in the population. So this is the interpretation of our group statistics for SPSS t-test for 2 independent samples. Note table number 2, independent sample test. This table is divided into 2 groups. One is Leibniz test for equality of variances, first group. Second group is equality of means t-test. First one is Leibniz test, second one is t-test. Now 2 rows are given. Equal variances are assumed. Name it as row number 1. Equal variances are not assumed. Name it as row number 2. This test is used to find out which row to read from. Larger the variances means on average the data values are away from their mean. Now here significant value is greater than 0.05. So we accept Leibniz test null hypothesis. Leibniz test null hypothesis is accepted as p-value is greater than 0.05 at 5% level of significance. Our H0 is Leibniz H0 is equal variances are assumed, and H1 is equal variances are not assumed. Means high protein group and low protein group have equal population variances. When H0 is accepted in Leibniz test, we should use row number 1 for data analysis. Again, very important point. When H0 is accepted in Leibniz test, we should use row 1 for data analysis. When H0 is rejected, we should use row number 2 for data analysis. Means if p is less than equals to 0.05, read from row 2. we should have read from the second row. This is the importance of Levin's test over here. So we are using first row for data interpretation as our H naught is accepted. Name the column as for better understanding. Name the column as A, B, C, D, E and F. Here A column is T stat, statistical value of T. Where A equals to ratio of mean differences and standard error differences. Means D divided by E. 3 divided by 1.256, which is approximately equals to 2.389. So T stat is 2.389. B column is degree of freedom. Sum total of all the observations means N1 plus N2 minus 2. N1 is observations of first group, N2 is observations of second group, minus 2 comes out to be 10. So degree of freedom in our question is 10. Now next very important column, C, p-value column. Here p is less than or equals to 0.05 at 5% significant level. Therefore t-test null hypothesis is rejected, which means additional protein increase the weight of the chickens. You can conclude that there is a statistical difference between the two groups. Means additional protein increases the weight of the chickens, as H naught is rejected, as p-value is less than 0.05 at 5% significant level for two-tailed test. So this is the result of our hypothesis testing. So C column is very important. Then mean difference. It is nothing. It is just a mean of high protein group minus mean of low protein group. As we have done in previous table, mean of high protein group is 14 and low protein group is 11. So their difference is 3. So D column is mean difference. Then standard error differences already explained in previous table. Then last column is confidence interval. Lower critical value and upper critical values are given at 95% confidence interval, 0.202 and 5.989 at 95% confidence interval. Means our unknown population parameter lies between these two values. Unknown population parameter lies between upper value and lower value. So this is an interpretation of output table of SPSS t-test, two sample independent test. So our final answer is p-value is less than 0.05. We reject H naught, means additional proteins increases the weight of the chickens. So this is our final answer by SPSS analysis. Now we will do pen and pencil. Question is again test of hypothesis about the difference between the two means in case of independent samples. First sample of 7 observations, weight of with high protein diet is given. Second group of 5 observations, 5 chickens. Low protein weight is given 8, 10, 14, 10 and 13 ounces. Now test whether there is a significant evidence, correct it over here, that additional protein has increased the weight of the chickens. So H naught is, our null hypothesis is mu1 equals to mu2. Means additional protein diet not increase the weight of the chickens. Additional protein has not increased the weight of the chickens. So this is our null hypothesis. If mu1 is not equals to mu2, then that one is alternative hypothesis. Now first draw table. X1 for high protein diet values 12, 15, 11, 16, 14, 14 and 16. Sum total of the observations is summation x1 equals to 98 and number of observations n1 in group 1 is 7. Mean of group 1 98 by 7 equals to 40. So we will calculate deviation from the mean. X1 minus mean of first group. -2, 15 minus 14, 11 minus 14, 16 minus 14, 14 minus 14, 14 minus 14, 16 minus 14. Square of the deviations from the mean. 4, 1, 9, 4, 0, 0 and 4. Sum total is x1 dash equals to 22. Now for group 2, second independent group, x2 8, 10, 14, 10 and 13 ounces. Here sum total is 55. Summation x2 is 55. Number of observations are n2 is 5. Two unequal groups are there. Two unequal independent groups are there. So mean of second group is 55 divided by 5 equals to 11. Again, square of the deviations from the mean of second group. Directly I am doing square. 9, 1, 9, 1, 4. 13 minus 11 is 2. 2 square is 4. Sum total is 24. Now we will calculate standard deviation for combined groups. Square root of or under root summation x1 dash minus x1 dash whole square plus summation x2 minus x2 dash whole square. Square of the deviations from the original mean over degree of freedom n1 plus n2 minus 1. By putting the values we get under root 22 plus 24 divided by 7 plus 5 minus 2. which comes out to be 2.14. 22 plus 24 is there, right? Now applying t-test. T-stat is t equals to mean of first group minus mean of second group divided by S, standard deviation, into product of number of terms of both the groups plus sum total of the number of terms of the both the independent groups, which is equals to 14 minus 11 divided by 2.14 into under root 7 into 5 over 7 plus 5, which is approximately equals to 2.394. So this is our calculated value for t-test, 2.394. Now degree of freedom. Degree of freedom equals to nu, degree of freedom nu equals to n1 plus n2 minus 2, means 7 plus 5 minus 2 equals to 10. So for nu equals to 10, t value at 5% level of significance for two-tail test is 2.28, which is our table value. So we have one is calculated value, another one is table value. One is 2.394, another one is 2.228, which means by comparing both the values, calculated value is greater than table value. Calculated value is greater than table value. Since the calculated value of t is more than the table value, the null hypothesis is rejected. Hence, there is a significant evidence that additional protein has increased the weight of the chickens, which means additional protein has increased the weight of the chickens, which is our final answer or analysis by pen and paper. First one was by SPSS, now by pen and paper. Additional protein has increased the weight. So this is our final analysis by SPSS and pen and paper. Thank you very much.